All right, number 11. I want to solve this using fundamental theorem of calculus. We're going to integrate from 1 to 9, 6 divided by t dt. Now again, this is one of those when you have that rational expression, I'm looking at the derivatives sheet to see derivative of something is 1 over x, because if you rewrite this as 6 to the t to the negative 1 power and you try to use the power rule, you have plus 1, and negative 1 plus 1 is 0, and you cannot divide by 0. So there's some other one. This is one of those that will be very familiar once you do it several times. Should be natural log. So we're going to go to our derivatives, and again we're looking for derivatives because we're trying to find the antiderivative of some function. Cheat sheets, handouts, and we're looking at our derivatives or differentiation. They both give you about the same information. One's a little more simplified. All right, so right here, common derivatives, you see how we have the derivative of ln of x is 1 over x, okay? They also have one that just shows you the absolute value is still 1 over x. So we are looking at the derivative of ln of x is 1 over x. So when we do the antiderivative, go backwards, we'll get ln. All right, the 6 on top is just a factor. So we're going to write this as 6 integrated from 1 to 9 of 1 over t dt. And then the antiderivative of 1 over t is going to be ln of t. Evaluated from 1 to 9. And then we will get ln of 9 minus ln of 1. Now also, if you are familiar with natural logs, log of 1 is 0, so this whole thing goes to 0, and we just end up with ln of 9. So just to kind of go back and show you, it doesn't matter whether you use log, log, or natural log, which is what we have in this case. They both behave the same. Log of 1 is 0. So this one just simplifies to ln natural log of 9. Are there two parts? Fundamental theorem. Okay, I'm sorry. Left off the multiple of 6. Gotta be careful. I wrote the 6 out front and forgot to bring it back down. So it should be 6 times ln of 9. That 6 will 0 out. 6 times 0. Gotta be careful with that multiple of 6. All right, we're going to evaluate this one using the fundamental theorem of calculus. One to 2. Now I'm going to write both of these divided by z so we can see it a little bit better, what to do. So 1z will cancel, leaving me with the integral of z, and then we'll have z over 5. So I'm going to write this as 2 separate integrals. Integrals from 1 to 2 of z dz plus, we're going to say 5 times the integral of 1 to 2 of 1 z dz. So even if they change the variable, it's still the same. This 1 over z is just like 1 over t. It's going to give me ln. Using the power rule, add 1, divide by 2. So we're going to have z squared divided by 2, and then plus 5 ln of z. Now I should have a plus c, but the plus c is going to zero out once we do upper limit minus lower limit. We will plug in a 2. 2 squared is 4. 4 divided by 2 is 2. But I'm going to show all that before I do too much. And then plus 5 times ln of 2. So this is plugging in 2 to the upper limit, and then minus, plug in 1. All right, so 4 divided by 2 is 2, plus 5 ln of 2, and then this will be minus 1/2, and then ln of 1 is 0, so just minus 1/2. So the 2 and the 1/2 we can combine, and that will give me 1.5 or 3/2. So 3 over 2 plus 5 ln of 2.